Hey guys, welcome to Code Talk. Today we are solving the problem print all triplets that form an arithmetic progression. This question was asked in the interview of Amazon, Flex and Dell. Okay, so it's kind of an important one. So let's look at the problem statement. It says, given a sorted array of distinct positive integers, print all the triplets that form an arithmetic progression with an integral common difference. So what does arithmetic progression means? A sequence of numbers such that the difference between the mod of the difference between any two adjacent numbers is same in all the sequence. So let's take the example over here of 5 and 7. The difference is 2. 9 and 11 2. 7 and 9 2. 13 and 15 2. Okay, so only we have to consider the adjacent elements, and the difference of all the adjacent elements in that particular sequence should be 2, same. Okay, in this case it was 2. So first of all, I will tell you how can you determine. So we have to only find the triplets, so not a sequence. Okay, like a sequence may contain any number of numbers, so we have to find only triplets. So let's take an number x. Okay, and we'll also take the common difference as 2. So the next element, okay, the element next to x will be x plus 2, and the element prior x would be x minus 2. To take a simple example, let's take the x is 7. So what will be 7 plus 2? It will be 9. And what will be 7 minus 2? It will be 5. So it is forming the same sequence. Okay, the triplets. So that's what this example is. So how can you determine that if this triplet which we are getting is a arithmetic progression or not? Okay, what we will do is we'll add this 2. Okay, so what is the addition? X minus 2 plus x plus 2. What are we getting? 2 gets cancelled and you get 2x. Okay, let's name this term as A, B and C. So A plus C equals to 2 into B. So this is the equation, okay, which we will be testing while we form any triplets when we are traversing, and we will check this condition. Okay, so you guys note down this formula. So see, as we see in this example mentioned over here, the triplets formed are 5, 8, 11 and 9, 12 and 15. The common difference here is 3, and even here the common difference is 3. Okay, so I will be solving this example as it is long, and also it will cover all the cases. Okay, so now let's jump to the intuition. So I've written down this same example over here, which I told you I will take for the explanation. So what we'll do is we'll maintain 3 pointers. Obviously you might have taken that into consideration, name I, J and K. So now how we will be traversing the array and what will be the time complexity, we'll discuss everything. So the algorithm will start from the second element, means the first index. Okay, means from here. We'll start our algorithm from here. What we'll have here is a pointer J. Okay, and now we have to place the remaining two pointers, namely I and K. And remember guys, this is a sorted array. Okay, this is the most important point. Okay, J. Now what we'll do is we'll place the ith pointer previous to the jth pointer, and kth pointer next to the j pointer. Now you guys might have understood why I am starting from the second index, means the first index, and not the 0th one. Okay, and we'll perform the technique or the solution, this formula which I mentioned over here. Okay, so in this case, this is A, this is B and this is C. What the formula says, I'll write it down. A plus C is equals to 2B. So what is the value of A? 1. Value of C? 5. 2 into. Value of B is 3. 6 equals to 6. Yes, this satisfies our condition. Okay, so this is our first triplet, 1, 3 and 5, and we will store this in a list or something, or we will just print it out. That depends on us. Okay, you guys please note down this formula. Again, I am reminding you. Now we have formed an arithmetic progression over here. Now what the condition is, whenever we will find an arithmetic progression or a triplet which forms that, we will increment the k. Okay, we will increment the k pointer and decrement the I pointer. It means I will go over here and k will come over here, but there is no value or any element over here, so this loop will get terminated. Okay, this loop will get terminated. Now what will happen? Now the j pointer shifts over here. Okay, we are just moving the j pointer, and the I and k pointer are internal to the j pointer. Okay, so what I said, I pointer is prior to j, k pointer is next. Now we will see the other two conditions when the triplets are not getting formed. So how will the I and k pointers move? Okay, let's take this condition. What is value of a? 3. Value of c is 6. So 2 into 5, 9 and 10. Okay, so now the value which we are getting, okay, by addition of these two is less than the double of the middle value. So now we have to increase this sum, then only we can get the value which is present in the middle. So if now this is a logical thing, if we move the I pointer, we cannot move the I pointer forward, right? We have to move the I pointer backwards. If we move the I pointer backwards, the value will obviously get decreased. Why? Because here this is 3, so obviously an element less than 3 will be present prior, because this is a sorted array. Again I am saying a sorted array, and obviously an element greater than 6 will be present over here. So we will increment the k pointer if the sum of these two values is less than the middle one. Okay, so what will happen is k will jump over here. I'll even erase this. Again you have to perform the check. So what is the check? 8 plus 3 is 11, and 5 into 2, it's 10. No, it's also not getting formed. Okay, it's even not forming an triplet. Now the condition is the sum of these two elements is greater. See, 11 is greater than 10. It means the sum is greater than the double value of the middle element. Now we have to decrement I. In this case what we will do is we will decrement the I pointer, and k will remain as it is. Okay, we will decrement the I pointer. Now what the value is? 1 plus 8, 9, 5 into 2, 10. Again, now what is happening? The sum of these two elements is less than this. So again we will increment the k pointer. Okay, k pointer comes over here. Now I and k, what is the addition? 1 plus 9, it's 10, and 5 into 2, it's 10. Yes, this is forming a triplet. See, okay, I have covered all the cases where the value of the sum is greater than the double of the middle element and less than the middle element sum. Okay, so now in this case we are forming a triplet. Our first triplet was 1, 3 and 5, and second triplet is 1, 5 and 9. Now what I told you guys, whenever a triplet is formed, we will increment k and decrement I. So again, if I decrement I, it's going to the position where there is no element present. So we will shift the j pointer now. Now j pointer comes here, I goes here, and k goes here. Okay, now again addition 8 plus 5 is 13 and 6 into 2 is 12. So this sum is greater. So what we will do is decrement I. Again we will take the sum. 8 plus 3, 11, 6 into 2, 12. What is this sum? It is less than. So now we will increment k. K comes 9 plus 3 is 12. 6 into 2 is 12. Tada! Again it is forming a triplet. 3, 6 and 9. 3, 6 and 9. I will erase this. Now what? Again we have to increment k, decrement I simultaneously. I goes over here, k comes over here. 15 plus 1 is 16. 6 into 2, it is 12. So what is the condition over here? It is greater. The sum is greater. So we have to decrement I. Again I is going at a position where no element is present. So now it's time to shift the j pointer. J pointer comes over here. We have I and here we have k. 9 plus 6 is 15. 8 into 2 is 16. This value is less than 16. So again, then we'll increment our k pointer. When we increment our k pointer, what do we get? 15 plus 6. It becomes 21. So yes, 21 is less than 16. So we'll decrement I. Okay. (15 plus 5, 20). Again I will get decremented. It will be 3. 15 plus 3 is 18. Again it will get decremented. It will come over here finally. So what is 15 plus 1? It is 16. Again a triplet is getting formed. So next time our value of triplet is 1, 8 and 15. Now what we will do, as you know, this will get terminated, so I am not covering all the cases over here. Value of j pops up here, I and k. Okay, this is 23 and this is 9 into 2, 18. Okay, I am not doing the steps because now I have explained it for many examples. 23. So this value is greater than 18. Okay, so I comes over here. This gets cancelled out. So what is the sum? 6 plus 15, 21. Again this value is greater. I comes over here. 15 plus 5, 20. This value is yet greater. 15 plus 3, 18. Finally a triplet again. Now this time the triplet is 3, 9 and 15. 3, 9 and 15. So what we have to do? We have to increment k. So there is no place for k. So the loop is getting terminated. Why it is getting terminated? So I'll tell you. If I place the j pointer here, there is no place for the k pointer. Like here, I am not placing the j pointer here because there is no place for the I pointer. So how many triplets are getting formed? 1, 2, 3, 4 and 5. Okay, so 5 triplets are getting formed over here. So now I will show you guys the code, and I will even mention the link for the code in the description. Okay, so this is the code over here. I've written down the same example over here, right? And I have given a call to the function find all triplets. So let's see if the value or the length of the triplets is less than 3, as we are finding the triplets, and if the length of the array is not even 3, so how can we find the triplets? Okay, so we'll return it and we'll terminate. As I said, I'll start from the first node and I will go till -1. -1 means till here. Okay, till here, and I will start from here. Right. So as I said, the I pointer will be j minus 1 and k pointer will be j plus 1. And what is the termination condition? Termination condition means if when the value of I will come over here prior to this, means -1, and the value of k will be greater than the length. What is the length? 1, 2, 3, 4, 5, 6, 7. If the value of k is 7, then the loop will get terminated and we will increment the value of j. I am checking the condition if a of I plus a of k is equals to 2 into a of j. I explained this formula to you guys. So this is equivalent to a plus c equals to 2 into b. Okay, this is equivalent to that. If this condition is satisfied, then we'll print as it is a triplet, and I said we'll increment k and decrement I. Otherwise, we'll check if the sum is less than the double into the middle element, then we'll increment k. Why? It is a sorted array, and I even explained the concept. Otherwise, we'll decrement I or increment k. And this is how the loop will run. So we'll check for the output. How many are getting? 1, 2, 3, 4, 5. As I mentioned over here, 1, 2, 3, 4, 5. Okay. So guys, if you like the content, if you are understanding the videos, please like the video and share this with your friends, and do subscribe to my channel. Stay safe. Thank you.